Hello, in this video, I'm going to continue the previous part of derivatives where I stopped from. So in this part, I'm going to tell some methods of doing derivatives, of differentiating various functions. There are two or three methods that I know. One is substitution method and another is logarithmic method. And there is a one more method. It is known as implicit functions method. In that method, there is a function of x and y which is equal to 0. Then we have to find dy by dx for it, which is derivative for that function. So I'm going to take one example for that particular method in this video. So let's get started. Before telling these methods, I'm going to derive the differentiation, derive the derivative of a function deeply. Okay, so let's say if I take a function, it is a random function like this. Sorry, this looks terrible. Okay, let's say I took a function like this. At a point, let's say this is a point x for this function, and this is a graph of y is equal to f of x function. This is a graph of y is equal to f of x. If this is x, then this point will become f of x. So it's like that. Okay, and this point is 0, 0. Okay, let's say okay, the derivative of a function is the slope of the tangent at this at any particular point for this function. As we know that I've talked about it in previous video. So at a microscopic level, I uh, if I go h distance in x direction, so this particular point becomes x plus h. Okay, if this is x distance, this full distance will be x plus h. This full distance will be x plus h. Okay, and if this point is x plus h, then this particular point in the y-axis is f of x plus h. Okay, so in this example, we know that h is very small, so h tends to 0. H is very small. We are talking on a very small amount of scale, a small scale of number. So h is very small. H is tending to 0. So we know that for 2 points, x1 comma y1 and x2 comma y2, slope for these 2 points is y2 minus y1 over x2 minus x1. So we are going to use that particular formula here. So slope for this particular function is f of x plus h. In this example, we know that y2 is f of x plus h and y1 is f of x. x1 is x and x2 is x plus h. Let me write down those things here. Y1 is f of x1 x and y2 is f of x plus h, and x1 is x, x2 is x plus h. Okay, so I'm going to substitute this values right here. F of x over x plus h, x2 minus x. So if those 2 points are distinct points, then this is the slope for that particular function. But as we know that we are talking on a microscopic scale, and h is tending to 0. So we have to put limit for this thing. So for this thing, this is going to be limit when h tends to 0. Now this is uh, we can say that now this is a slope for that function on that small point. So the x will cancel in the denominator, and we get the formula as limit when h tends to 0. Remember, the h is the small distance. Okay, f of x plus h minus f of x over h. So this is the slope for the function, and this is also the dy by dx. Dy by dx. Okay, dy by dx thing. Okay, so that's how we get that formula. This is the fundamental formula for derivatives. So this is how we get that formula. This is the theoretical derivation for this formula. So let's get to um, the thing we are talking about, the methods for differentiation. So I'm going to talk about first method for differentiation, or substitution method. So uh, if a complicated function is given to us and we don't know what to do, then we can substitute any variable in that function with another function, so that we can simplify that function, and after that we can find the derivative for that function. We usually do substitute. Yeah. Okay, sorry for the interruption. Where are we? So we typically use trigonometric functions. We use usually trigonometric function to do this substitution method thing. So let's get on to the problem right away. So this is a problem. You can see that it is very big problem, very massive problem. If y is equal to this function, tan inverse of root of 1 plus x square plus root of 1 minus x square over root of 1 plus x square minus root of 1 minus x square. For x mod x is between these 2 points 0 and 1, these two numbers, we need to find dy over dx. That means we need to find derivative for this function. So we cannot so we cannot we need to find a smaller approach. So we can use substitution method here. So what I'm going to do is substitute this thing right here, x squared as cosine of 2 theta. Okay, so I'm going to do that. If I substitute x squared as cosine of 2 theta, then let's write this term right here. Y is equal to tan inverse of root of that x squared becomes cos 2 theta. We have plus on the top. Okay, plus on the top, and this is 1 minus cos 2 theta over root of 1 plus cos 2 theta minus root of 1 minus cos 2 theta. If you know the trigonometric multiple angle formulas, you know that 1 plus cosine 2 theta is 2 cos square theta, and 1 minus cosine 2 theta is 2 sine square theta. So yeah, so this becomes this like this. Okay, zoom out. So let's do that thing. We have tan inverse of. So I'm going to do this thing first and write this thing in here in the argument thing. I'm going to simplify the argument thing first without writing it again and again. So this becomes 2 cos squared theta plus root of 2 sin squared theta over root of 2 cos squared theta minus root of 2 sin squared theta. Okay, I'm going to write S simply. S and C for cosine and sine functions. So if I take root 2 on common on the top, I am left with cos theta plus sine theta. Because the square and the root will get cancelled, and on the bottom also I am left with cosine theta minus sine theta. So the root 2 gets cancelled, and I have this thing right here, cosine theta plus sine theta over cosine theta minus sine theta. And now comes a crucial step here. If I divide and multiply, sorry, if I only divide cosine theta top and cosine theta on bottom like this, then I'm going to multiply that, and this will become 1, and this term becomes here sine theta over cosine theta. Let's give parenthesis to them, and this okay, sorry, this term right here becomes sine 1 minus sine theta over cosine theta. Okay, so 1 plus sine over cosine is tangent of theta. So this becomes 1 plus tan theta over 1 minus tan theta. So one more thing you need to know is tan of A plus B formula. Tan of A plus B. It is tan A plus tan B over 1 minus tan A and tan B product. So we can relate this thing with this thing. So we can see that here tan B is theta and tan A is 1. So if tan A is 1, then A should be 45 degrees. As we know that tan 45 degrees is 1. So if tan A is 1, so then A has to be 45 degrees. So by comparing that thing right here, so let me write that clearly. This is, we can write this as tan pi by 4, which is 45 degrees. I'm going to write this in radians. Okay, this thing is tan theta, tan pi by 4 minus plus tan theta, and tan pi by 4 minus tan theta. So by comparing this thing with this thing, I can write simply as tan of pi by 4 plus theta. Simply like that. So we simplified the argument thing, and let me write down here. So that becomes tan inverse of tan of pi by 4 plus theta. So the inverse and the normal function gets cancelled with each other, as we know that in the inverse functions, tan inverse of tan x is 4. Terrible thing. As we know that tan inverse of tan x is simply x. So by using that particular thing right here, we can what we get is pi by 4 plus theta. So we got y is equal to pi by 4 plus theta. So we don't have any x terms right here. We have theta terms. In terms of theta, we need to use this relation right here to find the theta here. Okay, theta. So as we know that we substituted x square as cos 2 theta. If I take cos inverse on both sides, this becomes cos inverse of x square, and this becomes 2 theta. Okay, and you know that cos inverse of cos x is also simply x. So by using this, okay, sorry, this thing right here, we can do send this cos to this side. It becomes cos inverse of x square, and to solve for theta, I'm going to divide 2 on both sides, so I get cos inverse of x squared right here. So theta is simply cos inverse of x squared over 2. So I get y is equal to pi by 4 plus 1 over 2 cos inverse of x squared. So I simply got our y function like this, and we simply need to find, we can simply differentiate now. So differentiation of constant is 0, and this is a constant, so we can put it like this, and we know that differentiation of d by dx of cos inverse x, it is simply negative 1 over root of 1 minus x squared. This x is what is in the argument of cos inverse. So 1 minus x squared whole squared. So we need to apply the chain rule here also. We need to differentiate this again. So x squared prime, differentiation of x square, multiply with this thing, and we need to multiply again by differentiating x, what is in this thing. So that is the chain rule. I have taught about it in previous video. So now this is the particular result we got here. We get dy by dx is equal to negative 1 over 2 times root of 1 minus x squared whole squared. Is this two powers get multiplied, so it becomes x power 4. This become the differentiation of this thing right here is 2 times x power 2 minus 1 using x power n rule. So this becomes 2 times x, and the differentiation of x is simply 1. So this 2 gets cancelled, and I got minus x over root of 1 minus x power 4. So this is the dy by dx value for this huge function right here. So as you can see that we simplified this thing by using by substituting a trigonometric function and using trigonometric identities to simplify the function, and at last differentiating it by the rules, by the basic rules we have studied in previous class. So it's not that complicated if you do practice these things. So let's move on to next problem. This is also a problem like previous one. So this is not a big problem like previous one. Previous problem is a massive problem with massive calculations. So as we've seen in previous problem, as we've seen in previous problem, we substituted x square with this cos 2 theta to get this format, because it is in the square root, and we get this result, and we can square root cancel this thing, square and root cancelled, and this thing is cancelled, and we can Okay, sorry. We are left with simple trigonometric functions, and we can simplify that as anything we want to simplify this whole thing. So, like we used in previous question, I'm going to substitute x with cos 2 theta. Okay, you can use sine 2 theta also, but it is not a simple formula like this thing right here. It is not a thing. Okay, you need to do different approach, but this approach is small and easy. So I'm going to use simply cos 2 theta formula. Okay, so we get y is equal to tan inverse of root of 1. Okay, 1 minus cos 2 theta over 1 plus cos 2 theta. So by using the formula, by using the identity, 1 minus cos 2 theta is equal to 2 sine squared theta, and 1 plus cos 2 theta is equal to 2 cos squared theta. Okay, so let's use that. I'm going to first simplify this argument thing. So this becomes 2 sine squared theta over 2 cos squared theta. Two 2's gets cancelled, and I'm left with sine square theta over cos square theta is tan square theta. Okay. Theta and the square root gets cancelled, and I'm left with simple tan theta. I am left with modulus of tan theta, but as oh sorry, what the hell is this? As the x is less than mod x is less than 1, that means x is between -1 and +1. So x is also can be positive, so this tan theta is going to be a positive tan theta. So this thing right here is tan theta, and this is the argument thing. Okay, so here we get y is equal to tan inverse of argument is simplified as tan theta only. This tan and this tan inverse gets cancelled with each other, and I am left with y is equal to theta. And like previous problem, we need to solve for theta. So we got x is equal to cos 2 theta. If we inverse on both sides with cos, so I get cos inverse of x is equal to 2 theta. And if I solve for theta, I get 1 over 2 cos inverse of theta, x. Okay, x 1 over 2 cos inverse of x. So I get y is equal to 1 over 2 cos inverse of x. Now I need to find dy over dx for this. So 1 over 2 is constant, and the differentiation for cos inverse x is -1 over root of 1 minus x squared. I do need to multiply with x prime right here, by using chain rule, but it does not affect anything. So I am left with 1 over -1 over 2 times root of 1 minus x squared. This is the solution for this problem. It is simple, but the approach is same like previous problem. Okay, so this is the substitution method I need to tell you about. Let's move on to another method, which is known as logarithmic method for differentiation. Okay, we use logarithmic method when we find variables in powers. Okay, variables in powers means I can get x power y, cos x power x. Variables like this, those we not need we oh sorry we don't know formula about d by dx of x power y like that. So we need to simplify those things using logarithms. Let me give you basic idea. So let's say I have y is equal to x power y. Okay, let's say I have this thing right here. I need to find dy by dx. So what I'm going to do is take log on both sides. So ln y becomes ln x to the y, and using logarithm properties, this power comes right here in multiplication. So I'm left with y ln x. And now I'm going to do is differentiate with respect to x on both sides. So I'm going to differentiate with respect to x. So we know that d by dx of ln x is equal to 1 over x. So I'm going to differentiate with respect to x. So dy dx of x, dy dx of ln y is 1 over y times dy over dx using chain rule. Okay, let me tell you this part briefly right here. So we are finding d by dx of ln y. So like basic this formula, the right here we have argument y. So I'm going to do y. Then using chain rule, I'm going to differentiate the argument part again. So argument part differentiating again. So like this, by using chain rule, I get this thing. Okay. So yeah, it's like that. And this are two are like d by dx of f times g. These are the we can use product rule here. So y ln x prime plus ln x into y prime. Y prime is simply dy by dx. Okay. So 1 over y times y prime plus, okay, sorry, not plus. I'm simply writing y as y prime, okay, not writing this again and again. So we know that ln x prime is 1 over x, and we need to multiply x prime over here. So it is simply 1. So we ignore that, and this is ln x times y prime. We need to find dy by dx. Dy by dx is y prime. Okay, dy by dx is simply y prime. So uh, let me take this thing on the left side, or I can say that I'm going to subtract this thing on both sides. So 1 over y times y prime minus ln x times y prime is equal to y over x. Okay, if I take common y prime, I am left with 1 over y minus ln x is equal to y over x. Okay, and let me do one thing here. I'm going to sorry, nothing. Okay, nothing. I cannot simplify this thing. Okay, and I divide by this term on both sides. I can get y over x 1 over 1 over y minus ln x. We can simplify this thing right here by multiplying uh, y and y this thing. So this y gets cancelled, and I get y over x times y over 1 minus y ln x. So this becomes y squared over x times 1 minus y ln x. Now this looks more simplified. Okay, so like this we use logarithmic method. This is logarithmic method. So let's move on to problems. Okay, so you can see that. Okay, let me zoom in. Okay, now it's more clear. Okay, let's solve this using logarithmic method. So we have two things right here. So what I'm going to do is I make this thing. Let's assume this thing as v, and let's assume this thing as u. So I get y is equal to v plus u. Okay, and I'm going to do is differentiate with respect to x. We need to find with respect to x. We need to differentiate with respect to. Let's differentiate with respect to x. So I get dv over dx and du over dx. Now I need to simply find dv over dx and du over dx separately. And if I add those two things, I get my final thing that I want. It is dy over dx. So let's do that. Okay. So I know that I assumed v as x power tan x. Okay. On the right side, I assumed u as what? Sin x or cos x? Sin x power cos x. Okay. So let's do the thing we know. I am taking log on both sides. So ln x power tan x. So by using logarithmic property, this power right comes right in the multiplication. So this becomes tan x times ln x, and by simply I can differentiate with respect to x. Okay, so I get 1 by v for ln v, and I need to differentiate this thing right here with respect to x using chain rule. So I'm going to differentiate it again, and this is tan x times ln x. So this is product. We use product rule for these two functions, and this becomes tan x times ln x. Differentiation is 1 over x plus ln x into tan x. Differentiation is, okay, sorry, it is not tan x. It is tan x differentiation is secant square x. Okay, so I only need dv over dx, so I'm going to multiply v on both sides. So I get dv over dx as v times this thing right here. Okay, this thing right here. So uh, we have extra term here, extra variable here. So I know that v is x power tan x set. So let's put that thing right here. So this is x power tan x, and we have tan x by x, tan x by x plus secant square x ln x. So we got dv over dx. So we know that to get our answer, we need dv over dx and du over dx. We got this thing right here. So let me tick. I need to find du over dx now. So one part of the question is completed. So let's do another part. Okay, let's take ln on both sides, and cos x times ln of sin x. I wrote it simply, not doing another step. So let's differentiate. Ln u differentiation is 1 over u, and by using chain rule, I need to differentiate. Okay, if you are when you are differentiating with respect to x, you get terms like this when there is another variable. If you are differentiating x variables using x, you get at last dx over dx, which is 1. So it is a point to notice that why we get like this. Okay, because it is a different variable. Okay, what the fuck? Okay, so we need to use chain rule for these two different functions. So cos x times ln x differentiation is 1 over x In case we have sin x in the argument, then we need to differentiate sin x using chain rule again. So sin x differentiation is cos x, and we need to differentiate x again. So x prime cos x times x prime. Okay. Okay, let me write clearly here. Cos x times x prime. This is plus uh, now ln of sin x times differentiation of cos x is sorry. Differentiation of cos x is negative sin x. Okay, we got this big terms right here. So let's simplify that. We need only du over dx. So if we multiply both sides by u and u, this u's gets cancelled, and I got u times this whole thing right here, and u is sin x power cos x times cos square x over sin x, cos square x over sin x plus, no sorry, minus, because we have a negative term right here. So negative times positive is negative. Opposite signs gives negative, and same signs gives positive answer. So this is minus sin x times ln of sin x. So we got the du over dx term, and we got the dv over dx term. If we add those terms, we get dy over dx. Basically, the question is solved. We need to just write the answer. I'm not going to do that. This is very lengthy answer. As you can see, this term right here plus this term right here is the answer. So yeah, I only taught you how to solve this thing. Okay. So this is how we solve this problem. And there's one more problem right here that we need to solve. Okay. I need to find derivative of this thing and this thing right here, and then I get this thing right here as an answer. So yeah, we need to do that thing we did earlier. Assign this as v. Let's get right into solving this problem fastly. Okay, let me assign this as v and assign this as u. You can assign anything. Okay, so I get v as x power y, and sorry, v as x power y and u as y power x. Ln v is equal to y times ln x, and this is 1 over v. Sorry, this is 1 over v times v prime. Okay, and this is y times 1 over x plus ln x times y prime. I used product rule right here, and this is chain rule. Okay, and this becomes, let's solve this thing right here, and this becomes x ln y, and let's differentiate. This is 1 over u times u prime. This is ln x times 1 over y into, sorry, x times 1 over y into y prime. Y prime is dy by dx, and this is ln y times x prime is 1. Okay, so we got these things right here. So we need to find v prime is equal to we know that v prime is equal to this v times y over x plus y prime ln x. V is x power y, so this is x power y times y over x plus dy by dx times ln x. Let me write that. And here we have u prime is equal to u is y power x. Then I multiply u on both sides. Okay, this is x over y times dy by dx plus ln y. Okay, so I got u prime and v prime right here. This is v prime, this is u prime right on the right side. So we have v plus u is equal to a power b. A power b is not any variable, so this is a constant. This is k constant. And if I differentiate on both sides, I get v dash plus u dash is equal to 0. Okay, remember one thing, I'm differentiating with respect to x on both sides. Okay, in like I did in this example, I did, okay, sorry, this will not look like as v prime. Okay, this is v prime is equal to this. So v prime is this. On the upper result, we got v prime plus u prime is equal to 0. So v prime is x power y into y by x plus y by x plus y dash times ln x. I think, is it ln? Okay, it is ln x plus x power y. Sorry, y power x. It is y power x times x by y into y prime x over y into y prime plus ln y. ln y is equal to 0. And if I solve for y prime in this for this equation right here, I get the upper result right here. So let's solve for y prime. Okay, so to solve for y prime, I need to isolate y prime only. So let's multiply this with this x power y over x plus x power y prime ln x plus y power x into x by y times y prime and plus y power x times ln y is equal to 0. So to isolate only y dash terms, y prime terms, let's send the other terms on the right side. So they get negative. So if I take y prime in this terms common, in these two terms, only these two terms have y prime common. So I get y x power y ln x plus y power x into x by y. And if I send those two terms on the left side, on the right side, I get minus y power x ln y minus this thing right here and this thing right here, x power y by x. X power y times y by x. Okay. So if I divide this thing on both sides, I get y prime only. And if I take minus on common, I get y power x ln y plus x power y by x over this thing is x power y ln x plus y power x into x by y. And if I simplify this thing also, this thing is dy over dx is equal to negative y power x ln x. Sorry, ln y plus x power y minus 1. This is x power 1 on the denominator. If it goes on the top, it becomes negative 1. If we combine that, we get this thing, y minus 1. and this is x power y ln x plus x times y power x minus 1. So if you compare this result on the top, okay, this is very lengthy problem. So yeah, we got this thing right here and we got this result right here. Those two are same, so we got the answer. So let's do the last problem for this video. This is a problem for f of x comma y is equal to 0. We have two variables. Okay, let's basically differentiate this thing right here with respect to x. We need to differentiate with respect to x right here. We know that with respect to x dx, so this becomes 3x squared minus plus 3y squared times dy over dx using chain rule, okay, minus 3a. 3a is constant, and we got the product of two different variables, so this becomes product rule. This is x times dy over dx plus y times dx over dx. Dx over dx is basically 1, okay. On the right side we have 0. Okay, sorry for the interruption. Okay, so I get I can take 3 common out on this side, or I can divide both sides by 3. So divide, if I divide both sides by 3, this 3, this 3, this 3, this 3 will get cancelled, and I am left with x square plus y square times dy over dx minus a times. Okay, let's expand this thing. Minus ax dy over dx minus ay is equal to 0. Dx over dx is 1. So if I take dy by dx common, I get y squared minus ax. And if I send this term and this term on the right side, the signs will change. This minus ay becomes plus ay, and plus x squared becomes minus x squared. And if I divide both sides by this thing right here, I get only dy over dx as ay minus x squared over y squared minus ax. So this is the solution for this problem. Ay minus x squared by y squared minus ax. Yeah, this is the solution for this problem. So okay, basically that's it for this video. I'm hoping you enjoyed this video. So let's go. So okay, bye bye.